Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. E2 elimination requires anti-periplanar geometry between the H being removed and the leaving group, Br. The reaction proceeds in a single concerted step with strong base, now H acting as base. Moving on to the next step. The substrate is a transfused or trans-substituted bicyclic compound. From the drawing, it appears to be a system where a cyclohexane ring is connected to a cyclopentane ring bearing a CH3 group. The carbon bearing Br also has an H on a wedge, and the adjacent carbon at the ring junction also has an H on a wedge. The CH3 is on the cyclopentane ring. Moving on to the next step. For E to the H and Br must be anti-periplanar, 180 degrees dihedral. In the depicted conformation, we must identify which H is anti to the Br. And for the final step, the starting material shows a trans relationship between the H on the carbon bearing Br and the H on the adjacent carbon. In the drawn conformation, the H at the ring junction between cyclohexane and cyclopentane is on a wedge bond, and the Br is also shown. For antiperiplanar elimination, the H that is anti to Br on the adjacent carbon must be used. Determine which H is anti to Br given the stereochemistry shown, both H atoms on wedge bonds at adjacent carbons, with Br also on a wedge-like position. The antiperiplanar H is the one at the ring junction between the two rings. Elimination of this H with Br gives a double bond at the ring junction. Elimination gives a double bond between the two ring carbons, the junction carbon of cyclohexane and cyclopentane, producing a bicyclic alkene with CH3 on the cyclopentane portion. This corresponds to option D, a fused bicyclic structure, cyclohexane fused to cyclopentane, with a double bond at the ring junction and a CH3 group. A and B are substitution, SN2 products, not elimination products. E2 with now H, a strong base, poor nucleophile conditions, favors elimination. C shows an elimination product but with incorrect regiochemistry or stereochemistry. The double bond position or the ring geometry does not match the antiperiplanar requirement for the given stereochemistry. D correctly shows the double bond at the ring junction resulting from antiperiplanar E2 elimination, consistent with the given stereochemistry of the starting material. Therefore, the correct answer is D. Therefore, the correct answer is option D.